Today we are going to talk about how to use machine learning to predict the price of stocks in the future. Um, I would like to start with a caveat that this is an extremely difficult problem, so do not expect that we solve this problem and become millionaires overnight. At the same time, we want to take this as a challenge to understand more about how to apply machine learning in this complicated problem and how do we sort of improve our algorithm as we go along. Um, so we are going to use Python and different machine learning algorithms in order to be able to predict the price of stocks a few days ahead. The This is a swing trading setup. It's not a day trading setup. And what I mean by that is that we're going to predict what is the how a stock is going to do in the next week if we buy the stock today and sell it sometime next week. And we're going to look at historical daily stock price data and use machine learning to predict the best stocks to buy. So let's talk about the machine learning problem. Let us set this up as a machine learning problem. And I think that is extremely non-trivial. And there are a number of different approaches that we can take to set up this problem as a machine learning problem. We're going to take one of the more simpler approaches. We're going to treat this as a binary classification problem. Our input data is a time series of daily open, high, close, and low prices, and also the volume of the stock. If you want to see a sneak peek of that, maybe here if we go down, we'll see Apple, and we can see on a given day what is the close price, the high, low, open, and what is the volume of the stock that was traded, and similarly in the next day and so on. So that is sort of this time series is our input data. And then what are we trying to predict? So given this input data, we're going to create some features from this time series, and then we're going to predict a label that we're going to create. This label is kind of not easy to define. It would depend on how you are trying to trade, what is your sort of mechanism of trading, how you are putting your stop loss, and so on. And we will get to those nuances probably in one of the next videos. But for now, let's say that a possible label could be, did the stock go up more than 5% during the next week or not? And if the stock did, then it would be a positive label. And if it did not, it would be a negative label. And then we can play with that 5% number as we sort of go along and see what is a reasonable sort of increase in weekly growth that we can predict. So we start by reading the data. And again, I'll give a link to the data as well as to this notebook so that you can sort of follow along as I go. So this is some data that I've uploaded on a Google Drive, and it's sort of public, shared publicly. And then what I'm doing is sort of reading this data using pandas. And so I end up sort of reading that CSV file. It's a pretty large CSV file, so it takes a few seconds to read. And I'll change the date columns, and then we'll try to look at how many days of data we have. So we have about 661K data points. So this data corresponds to various stocks arranged alphabetically. So you see some stock with a symbol of A. And for each of these symbols, we have data for each date on the close, high, low, open, and volume. So we might want to start by visualizing the data, and there is some code here which I will not go into detail about, but it basically draws like a candlestick chart that is sort of more standard for trading algorithms. So the first thing that I'll do is look at one particular symbol. So we've chosen the Apple symbol, and we will sort of query all the data points that belong to the Apple symbol here. And I'm kind of implicitly assuming that they are in the proper order of dates, although you could sort of try to order them as well by date. And then let's look at the head. As you can see, it is properly ordered where we start with January 1, 2024, and we have sort of from January 1, 2024. If we look at the tail of this data frame, we'll have data till 7/12, and we'll see Apple sort of stock prices in that range of dates. So if we run our sort of candlestick chart maker, we will see sort of a candlestick chart of how Apple's stock price is doing starting from January to mid-July when we're sort of recording this video. So what are we going to do with it? So this is a time series which we cannot directly input into a machine learning algorithm. So what we want at the end of the day is to have one row of data for a single day of Apple. So this last day, for example, is one single day, and we would like to get some features based on sort of the history of Apple, or maybe the near-term history of Apple. So for example, we can see that Apple is sort of increasing. There is a huge momentum to the stock right now, and that is sort of a feature that we would like to sort of capture in our algorithms. And so we will come to the particular features that we capture, but we can start with how we want to capture these features in a efficient way in pandas. And this will become important as we sort of look at hundreds of or thousands of stock symbols and thousands of or hundreds of dates, and we'll try to construct these features. So we can go through this code where we first sort of take a data frame which contains basically this data with multiple symbols, multiple sort of dates, and corresponding prices. And then what we want to do is group by the symbol. So for each symbol, we would like to produce a set of features, and then we would sort of transform this grouped data frame. And when I talk about transform in pandas, what transform would do is to take one series and would return another series to me. It might be easier to see what we're trying to do if we look at the final result. So for example, we took the Apple sort of data for each of these days, and we produced a series of features which take into account the recent history of the stock, and each row corresponds to one symbol and one date here. And to do that, we basically take this grouped data frame, which is grouped by symbol, and we apply a transform, and in the transform, we apply a function. In this function, for example, is the Bollinger score. So the Bollinger score corresponds to something close to what we call the Z-score in statistics. So basically, we have this window, and we input a series to this Bollinger score function, and we return another series. And this series consists of the input series minus sort of the rolling average divided by the rolling standard deviation. So what we are saying is that the Bollinger score will say how many standard deviations away from the rolling average is the current sort of stock price. If it's much larger than the rolling, sort of many standard deviations away from the rolling average, which means that it is probably sort of overbought and will come down. The price will come down after a while. But that's sort of a feature that we want. Like how far away are we from the recent sort of rolling average, the average of the last sort of 20 days, for example. And that is what this feature is calculating. So we can at this point we can go into detail. So the Bollinger score. First, we look at we construct this rolling object. So in pandas data frame, we can construct this rolling sort of object which will allow different rolling window calculations, whether it's rolling average, rolling minimum, and so on. And maybe it is instructive to see what it's actually doing. So maybe this is a data frame with a single sort of column that we input, and then we want to see the rolling sum over two observations. So since we don't have two observations till now, the first one will be not a number, and then we have two observations, 0 and 1 here. So it will take these two, the sum of those will be 1, and then the rolling sort of sum of the last two values here would be 1 plus 2, 3, and so on and so forth. So if we come back to our sort of stock price, what we want to do is take the Apple data, for example, and we would want to construct sort of the rolling average. So a 2-day rolling average of the closing prices would be the average of this price and this price, for example. And a 5-day would be sort of the average of all these 5 prices. And then we might ask, like, how far away is the current price, which is 230, away from sort of the average of these 5 prices. And that would indicate how sort of overbought or oversold the stock is. But in sort of coming back to sort of the Python land, basically what we want to do here is we take a data frame as an input and we return another data frame as an output. So that is what our function is doing. And similarly, we have a function called moving average, which does the same thing. It takes the data frame as an input and it calculates sort of the rolling mean. We have to be careful in all these cases where the from 0 to Windows size -1 is always NaN when we do the rolling calculations, because we don't have enough numbers to sort of add up or average. So for example, in this first case, the rolling sum is NaN because we couldn't add up we don't have enough. So in that case, we sort of just replace it by the original values so that we don't end up with like NaNs in our sort of data frame. And we do the same thing in all our sort of calculations. So if we get back to all our technical indicators, so for each of these groups, we calculate the Bollinger score with a window size of 20. So we take the 20-day sort of moving average and we ask how far the closing price is compared to that. And then we join it to the original data frame and just change the column name to Bollinger score. We try to construct a similar or more features in a similar manner. So we construct a short moving average and a long moving average. So in trading, people try to generally look at 20 SMA or 100 SMA. Those are things that you would hear. So that means the 20 days simple moving average and the 100-day simple moving average, and those are what we are calculating here. And then similarly, we sort of join it to the original data frame. And then finally, we want to calculate the crossover. People want to know if the short moving average is larger than the long moving average, which means that the stock has momentum. Its short-term moving average is much larger than its long-term moving average. One thing I do want to point out here is that we divided by the long-term moving average because we want to normalize many of these values. So we're not going to look at Apple always. We're going to look at multiple stocks, and each stock and day, or each stock symbol and day, will have its own, will be its own sort of trading example. So we do want to normalize a lot of these features. And so we divide this by the long moving average in order to normalize this feature here. And then similarly, we try to normalize the short and long moving averages, and this is one possible way to normalize it. There can be other ways to normalize it, but this is one possible way to normalize, dividing by the closing price. And then we do more calculations of the technical indicators which are used in trading. For example, the stochastic K and the D. And basically what this measures is how far away the current closing price is from the rolling minimum. So we take a 14-day window and we say, what is the minimum price in this window? And what is the maximum price in this window? And then we say, what is the difference between the close and the rolling minimum, and divide and normalize it by the sort of the difference between the rolling max and the rolling min. And then there is the D-stochastic oscillator, which is the moving average of that. But basically, a lot of this calculation at the end of the day, what it tries to do is, as I was pointing out, it says that for a given day here, this is what we measure as the short moving average. This is what we measure as the long moving average. This is our sort of normalized difference between these two moving averages. This is how far away, this is the Bollinger score, which is like the C-score, which says how far away are we from the mean. And it gives one sort of example, training example for a given sort of day for this stock Apple. And then we also calculate something called MACD, which again is a difference between the short exponential moving average and the long exponential moving average. And we have the same setup where we take this grouped time series and the grouped data frame, and we transform by calling this EWMA function with a parameter span. And this is sort of defined in pandas, which is the exponential moving average in pandas. And the difference between the simple one and the exponential one is that the exponential one gives more weightage to recent data points, where the simple moving average sort of averages out all the sort of 12 or 20 data points that we might give it. So at the end of the day, we remove the symbol and the day, the sort of the closing and the opening prices and so on. And we call this with the Apple sort of data frame. Oh, sorry, we didn't define it yet. So let's go and define it. So we run this and we run this here. And then we sort of run this here. Yeah. So I want to take a look at the tail. So the tail basically shows us the most recent days, and the last one is 7/12. And you can see we have sort of a set of features that we have for Apple on this given day. So we have like 1, 2, 3, 4, 5, 6, 7 features. And so we can also look at the head, and I do want to see the head of this data frame to point out something for you. As we were mentioning, when we calculate these moving averages, the first few days we don't have anything, because we started with a 20-day and the 100-day moving average. So for 20 days, our short MA will be basically NAN in the not a number in pandas, and we sort of just put the actual original value of the data frame to replace that, so that we don't have NANs in our data frame. And you can see that's why these are sort of 1 and we cannot use it. So we will be able to use values starting from like the 101st day, because then the long moving average will be defined. And then we can take all those values as sort of our training examples. And then we did this for Apple. We could do this for the other sort of hundreds of different stocks that we have in our data set. And that is what we will do in our next series. We will define the label. We will generate a lot more training data by looking at all the different symbols. And then we'll sort of put them together and train a machine learning algorithm to see if we can predict the behavior of a stock in the near future, like next week, for example. Keep your eye open for that video to come. And thanks a lot for viewing this video, and thank you.